We are looking at one of the most spectacular glaciers in North America, if not the world. We are now into what is called Disenchantment Bay. Remember, the early explorers were all looking for the Northwest Passage. When they came to this area in the 1700s, it was ice-choked but navigable. They worked their way in here thinking maybe they had found the Northwest Passage. When they got past that point, they couldn't go any further. They discovered the glacier you're seeing and another one we'll see after a while, and they were disenchanted, and they called it Disenchantment Bay. Now, as you're looking to the right, to the starboard, you're going to see a lot of ice coming out of there. What that tells us is that this magnificent glacier is calving. That is a term that we get from agriculture. A glacier is giving birth to an iceberg. Now, calving is a natural process. It is not indicative in any way whatsoever of the term that we call global warming. We are in salt water. The glaciers are freshwater. They're snow that's compacted, hundreds and hundreds of feet thick, and pushed out almost all of the oxygen. Consequently, when the salt water interacts with the fresh water or the face of the glacier, it melts it. So a glacier is retreating only when there is more calving at the face of the glacier each year than snow falls in the high elevation. You are looking, as you're looking straight ahead right now, at a phenomenon of the 21st century. This glacier is growing, and it has been galloping. It began in the 1890s, and it continued in the 1980s and even in 2002. It is 76 miles. It goes back into the Yukon Territory, and it goes to Mount Logan. Mount Logan is 19,000 feet. Now, you know that Mount McKinley, many of you have been there, is 20,200 and some feet. So Mount Logan is one of the 3 tallest mountains in North America and in the tallest mountain in Canada. So this mighty glacier comes from Mount Logan. It flows 76 miles. It has a glacier to the right of it called Variegated Glacier. And Variegated Glacier is coming down at a very steep angle, sliding. And geologists and glaciologists believe that it is the sliding of Variegated Glacier that precipitated that galloping event that we have been experiencing now for the last 30 years. As you're looking at the face of the glacier, behind the mountain there is a large fjord that goes several miles, about 50 miles down to behind Yakutat. It is called Russell Fjord. And a fjord, by definition, is a U-shaped valley cut by glaciers, virtually no beaches, and rounded at the bottom. A river will create a V shape. A fjord is a U shape. In 1980, there is a small little island there called Osier Island on the other side of that large island. This glacier began to gallop, and it was moving so fast that ultimately it came down and it closed the aperture between Disenchantment Bay and Russell Fjord. When it did, Russell Fjord began to raise the water level 7/10 of a foot a day until it was 80 feet above sea level, suspended back behind the mountains and trapping wildlife and fish and threatening the livelihood and the existence of Yakutat, the village down below. In October 1986, there was a moraine and debris plug that closed that aperture. And it began to rain, and the rain began to interact with that huge geological plug created by the glacier. And in October of 1986, that plug broke. When it broke, it created the biggest transport of water in the history of the world. 3.7 million cubic feet of water per second came through that opening just on the other side of that island there. And in less than 36 hours, the Russell Fjord, which has now become Russell Lake, had dropped back down to sea level. Anything like that would have happened in an inhabited area, you would have a huge catastrophe. Now, in 2002, this happened again, and it happened in 1986. Whether it will happen again, we don't know, but This glacier that you're looking at, this monstrous glacier, one of the biggest in Alaska and still growing, it has been more studied than just about any glacier in North America. And you're looking at the Great Hubbard Glacier. Let me tell you a little bit about this ice. There is no difference from this ice than the ice on the face of the glacier. As the salt water interacts with the face of the glacier and it calves, it will give birth to huge icebergs, 20, 30, 40 feet. When they're over 20 feet, they're called icebergs. Now what we're looking at here is called brash. The larger pieces that are between these smaller pieces and the big pieces are called growlers. But remember, glacier, iceberg, growler, brash, all the same. Now, as you're looking at an iceberg and big pieces that are growlers, keep in mind that about 90% is underneath the water. They're incredibly dense, compacted. Now, as the salt water begins to interact with that ice, of course, it begins to melt. As it melts, it loses its density. As it loses its density, you see more of it. And so, oftentimes, you'll see a lot of blue in the ice. Ice is blue because it absorbs all the colors of the spectrum, but it reflects the blue. Now that's a layman's definition, but it's one that most of us can understand. Now as you're looking at the ice, you will see that there's a lot of black or brown in the ice. That is moraine, and that's what we call offshore transport. In other words, that's how the earth gets moved from one place to the other. And as the glaciers come down through the mountains, they literally grind and pulverize and polish and tear up the mountains, creating fjords, and then that ground up rock and debris and what we call silt becomes embedded in the ice. This is not pollution. This is part of the natural process of glaciers themselves. It's not uncommon to see great big rocks floating on an iceberg, and they may have come from that mountain 76 miles back for all you know. And as you get a better look at Turner, all of that black on both sides is really ice that's embedded with moraine. That's pulverized rock. And as you're looking at the glacier now, you're seeing the face and how huge it is. It's about 400 feet above the water and about 200 feet below. Got a great view of Turner with the mountains in front of it there, showing through the clouds.